Okay guys, jet fighter is flying horizontally at a constant height 210 meters with a constant speed of 140 meters per second. As it passes over a gun, the gunner fires a bullet with speed 70.5 meters per second at an angle tan inverse a half to the horizontal. If the plane of the bullet's flight is also the plane of the fighter's flight, find when the bullet will strike the fighter. Okay. In effect, it's a two-dimensional problem where we have. So this one here, the fighter is traveling in a fixed height of 210 meters, and it is traveling left to right. Okay, and the bullet is getting fired upwards extremely fast, and we're thinking that if they both start at the same point, that maybe the bullet will hit the plane maybe once, or what could be scenario B? It could potentially cross it twice. Okay, so we're just going to work with the gun to pick up some marks. You can get your Px, your Py, your Sx, your Sy before you get complicated. Okay, so let me see. 70√5. So 70√5 in this direction here, where this is alpha. This is going to be 70√5 cos alpha, and this one is going to be 70√5 sin alpha. Next thing we should do for these marks is find out what sine and cos alpha actually is. So we're told that it's a 1 and 2, so 1 is the opposite, 2 is the adjacent. I find that out by calling it tan alpha equals a half. That's the same thing as your angle is tan inverse a half. Okay? Using Pythagoras' theorem, we can find out that the hypotenuse is √5, and then we can find out what cos alpha and sin alpha are. Cos alpha being 2/√5, and sin alpha being 1/√5. Replacing these values in for cos alpha and sin alpha. So sin, when you replace it in for sin alpha, it's going to divide the √5 and multiply it by 1, so you're just going to be left with 70 going up. And when you replace cos alpha with 2/√5, what you're going to get is 140. Is that right? 140? Good with that? So it's 140 across and 70 upwards. Now, here's the interesting thing now. I have now figured out that I have now deduced that the horizontal speed is equal. Do you see that? The plane is going across at 140. So the plane is up here going across at 140, and we're just after figuring out that the bullet's velocity initially is going 140 across and 70 upwards. Okay? And because the 140 never changes, why does the 140 never change again?
No gravity.
No gravity, and we're not taking in wind resistance. That will slow it down. Okay, so the only thing we now have to worry about is when does the height become 210? So in a test, if you're saving yourself time, you're going to concentrate exclusively on Py and Sy, because the x distance is always the same. When the bullet is here, the plane is directly above. When the bullet is here, the plane is directly above, because the x values are the same, the phi x's are the same. Does that make sense? Okay, so therefore we're going to zone into Py. So Phi equals u plus at, and we're going to go for Py. Py is 70 meters upwards, minus gravity times time, minus gt. Sy, S equals ut plus a half at squared, and that's going to be 70t minus a half gt squared. If you want to substitute in what g is, you can. It's the same thing as 70 minus 9.8t, or the other one will be 70t minus 4.9t squared. Okay? G is 9.8.
Is that big gun?
Sorry? That's all gone. Okay? That's all the bullets. The other one, the jet, hasn't really got a formula because it's not a projectile, it's just going straight across the top. Okay, and as discussed there, the jet significance is gone now because it's the bullet, it will always be directly underneath the jet until it reaches the same height. Yep.
Is it not minus 9.8 G, so the minus and the minus will make it close?
What? No, it's minus gravity. See, it's V plus AT, and A is minus G.
Okay.
So that's why it's minus GT. Okay? Shh. Now lads, find when the bullet will strike the fighter. So we're looking at time here, okay? So what we want to find out is when you strike the plane, SY must equal 210. So SY being this equation here must equal 210. I'm going to multiply both sides by 10 and then bring this over to one side. So I'm going to get 49t squared minus 700t equals sorry, brought it over here, so that's already plus 2100. Got to divide by 7. 7t squared minus 100t plus 300. This will break up into 7t. I'd use the minus b formula realistically, but it's going to be 30 and minus 30. And is it minus 300 plus 300? Minus 10. Yeah. So that works out. And then you're going to get 7t minus 30 equals 0, t minus 10 equals 0, t equals 10, or t equals 30 over 7. Which one is it? So that's it there. It's the first time, because when you destroy the aircraft now, it is what we thought it'd be. It's actually scenario B, where the projectile goes above the plane. So it's going to be like the projectile is going to go through the height of the plane and back down again. But we're obviously assuming that it destroys it on the way up. There we go. Right? And not on the way down. It's already in tatters on its way down. Right? So we're on to any questions on that one? You good? Okay. Question 7. I think that's the bird one. A bird flies out of a tree exactly 5.6 meters directly above a hunter's gun and flies at a constant speed of 28 meters per second in a horizontal direction. If the speed of the bullet from the gun is 35 meters per second and the gun is fired just as the bird is leaving the nest, show that the angle of projection must be tan inverse 3/4 if the bullet is hit the bird. Okay, so what we're thinking is, logic would dictate if the bird is up here and the bird is flying directly across, like so, and you're down, your bullet is down here and it's on its way up and back down again, okay? So what that will dictate is that your bullet always has to be directly underneath the bird. Exactly like the last question. Would you agree with that? Because if the bird has a superior horizontal velocity, the bullet can't catch up. Okay? So what I'm trying to say is for every 28 meters the bird covers per second, the bullet has to cover 28 meters in the x direction to stay directly underneath it. And then the bullet, because it's faster, will also be rising while covering the 28 meters, going from left to right. That make sense? Any questions on that part? So, what we're going to have to do is we're going to have to say that the bullet is going 28 meters across per second. So what we can do is we can figure out the angle like this. So this is all to do with the bullet. 28 meters across, angle A. Its hypotenuse is 35. So what we're going to do is we're going to do Pythagoras' theorem here and figure out what the other side is. Call it y. So 35 squared equals y squared plus 28 squared. Will somebody tell me what 35 squared minus 28 squared is?
21.
So it turns out to be 21, yeah? Okay. Right. So by doing Pythagoras' theorem, it turns out to be 21. Now, tan A is opposite over adjacent, which is 21 over 28. And when you divide them both by 7, it's 3 over 4. You happy enough with that? 3 over 4. So this angle basically mimics a 3-4-5 triangle. 3, 4, 5, and that there can be my angle A. From this, I can figure out what cos A and sin A are. Cos A is 3 over 5, and sin A is 4 over 5. Any questions thus far? That's all to do with the direction. No? Okay. And so okay, so done that first part. Show that the time taken for the bullet to reach the bird is 2/7 of a second. We're talking about SY here, aren't we? So S equals UT plus a half AT squared. SY therefore equals U, which is going to be 28 across, 21 into the air, and 35 is the hypotenuse, right? So the U value of in the Y direction was 21. So it's 21 times T minus a half plus a half times minus 9.8 times T squared, which is minus 4.9 T squared. The height it has to reach is 5.6 meters. So SY is 5.6 equals 21T minus 4.9 T squared. Multiply everything by 10, and then once you multiply everything by 10, you can then divide by 7. So in a way, I'm multiplying by 10 and then dividing by 7. So what I'm going to get 49, 210, 56 divided by 7. That's going to turn into 8. That's going to turn into 30. And that one's going to turn into 49 divided by 7 is 7t squared. Move it all over one side, form your quadratic. 7t squared minus 3t plus 8. Now, 2 and 4. So 7t t equals 0. That's going to be a 4 minus 4, and that's going to be a minus 2. You have 2 times t equals 4, or 7t equals 2, t equals 2 over 7. You're going to hit the bird on the way up, not on the way down. Is that alright? Okay, so a dart player stands 2 meters from a dartboard. She throws the dart horizontally with speed u meters per second from a height 1.6 meters above the ground. The dart strikes the board at point 1.5 meters above the ground. Find the time the dart spends in flight, the initial speed of the dart u, and the speed of the dart when it hits the board. Now, we can do it 2 ways. Wonder what way they do it here actually. They use 11. Yeah, they did it the same way. They reset at point 1. So yeah, that makes sense. Okay. So What I'm saying is, why don't we just take the two heights away from each other and treat it as our baseline is 1.6. So what I mean by that is that I'm treating 1.6 as sy equals 0. And as the dart flies through the air, it comes back down underneath that line. And when it comes underneath that line, it's actually a negative sy value, because it's dropped underneath where it began from. So the sy value equals minus 0.1. Alright? Now, it wants the time that the dart spends in flight. Okay? So we have Sx information. Sx information is the horizontal distance travelled is 2 meters. And we know that the Sy information is minus 0.1. So we want to find how long did the dart actually spend in flight. Okay. Alright. We're going to start off with our two equations, phi x and phi y. Using phi equals u plus at. Phi x is going to be, she chose the dart horizontally, which means it goes straight across at u. So phi x equals u, and it has no acceleration, so that's grand. Phi y is 0. Oh, sorry, the initial velocity along y is 0, because it says you throw straight across. There's no upward or downward motion. So the u value will be 0, minus gt, because gravity is now dragging it downwards. So phi y equals gt, minus gt. And sx equals ut plus a half at squared. Once again, no acceleration in the x direction, so it's going to be u times t. Sy is going to be ut. Now, what did we say about the u value in the y direction? 0. So the ut is 0. And then we're just going to be left with the half at squared part, which is going to be minus a half gt squared. Alright. So, what we're going to do first is we're going to use our two items of information down here. Sx and Sy equals 0.1. So we're going to replace Sx with ut. Ut equals 2. T equals 2 over u. Is that right? Then this 2 over u, because that's the time it takes to hit the board and drop 0.1, we can now insert that into the Sy equation. So Sy now becomes a half g times 2 over u squared, and that has to equal minus 0.1. The minuses on both sides cancel to become pluses. That becomes a half of g, which is 4.9, and that's going to be 4 over u squared equals 0.1. Then I'm going to get 4 times 4.9, 19.6. 19.6 over u squared equals 0.1. I'm going to change the u squared and the 0.1 for each other. 19.6 over 0.1 equals u squared. U is going to equal 16. It's trying 16 meters per second across. So u squared equals 196. U equals 16. You happy enough with that? Now, I actually still haven't answered part 1 yet, have I? I actually managed to answer part 2 before part 1, just whatever method I chose. So what's going to happen next is I'm going to get my 16 and I'm going to put it, it's going to be 2 over u, isn't it? Wait a second. Sorry guys. So this here is 14. The square root of 196 is 14. Excuse me. So the time is going to be 2 over 14. which is 1/7. Takes 1/7 of a second to get over there. The speed of the dart when it hits the board. Now, guys, what does speed mean in particular as opposed to velocity? Velocity means how far along I are you going and how fast along J are you going. Speed means the hypotenuse of that. So what we know is that U never changes along the x-axis. So this U value of 14 is still the same as it hits the board. What we do need to find out, however, is what is the J component of your speed on the way down. The J component is your phi y. Your phi y is minus gravity times time, and we said that time is 1/7. So multiply that by that, and you should get minus 1.4. So 1.4 on its way down. You're next going to Pythagoras theorem this, and when you Pythagoras theorem it, what you get? I'm hoping 14.07. Anybody?
Yeah.
14.07?
14.07.
There you go.
7 root.
Oh.